So welcome to this video. In this video, we are going to discuss about working capital problems. So these are the topics that we are going to discuss in this video: inventory management, EOQ and EOQ with discounts, receivables and payables management. So early settlement discount for receivables and early settlement discounts for payables, cash management, Baumol model and Miller-Orr model, and finally computation of working capital requirement. So this entire chapter is only for 2 marks. So these questions will not like come in for the 10 mark or the 20 mark questions. So ensure that you understand the small concepts in this video, and then it would be like easier for you to crack the 2 marks. So we'll start from inventory management. So in inventory management, the first thing that we are going to discuss is the EOQ. So EOQ is equals to the square root of 2AB divided by CS, where A refers to the annual demand, B refers to the ordering cost per order, C refers to the cost per unit, and S refers to storage cost, and usually it will be given in a percentage. And to find out these, for example, if they ask you number of orders per year, then it's annual demand divided by EOQ. If they ask you frequency of order, it is 365 or 12 months divided by the number of orders per year. So that is how the formulas work. So we'll start with the problem. So we'll start from this problem. The purchase price of an inventory item is $25. So what is this? This is C. In 3 months period, the usage of the item is 20,000. So this is A. But what we want is annual demand, not 3-month demand. So we have to work out it separately. The annual holding cost associated with 1 unit equates to 6%. So this is the S of its purchase price. The cost of placing an order for the item is $20. So this is the ordering cost, which is B. So what is the EOQ they are asking? So we'll solve. So if we start, we first require the items. So we'll start from A. The 3-month demand is 20,000 units. So this represents 3 months. We do not want 3 months, we want 12 months. So that is about the A. So A would be 80,000. So we'll move on to the next one. B is directly given, which is 20. C is also directly given, which is 25. And S is also given, which is 6%. So we'll start with the EOQ formula. So EOQ equals to 2 into A, which is 80,000, into B, which is 20, divided by CS, 25 into 6%. So for the entire thing, we have to take a square root. So if we solve, the numerator comes to 32 lakhs and the denominator comes to 1.5. So the total answer here comes to 2133334. Again, it's a square root. So EOQ comes to 1461 units. Okay, so this is the EOQ number, economic order quantity. So economic order quantity refers to what is the number of units that has to be ordered in a single order. So that is EOQ. So we'll also find out what are the other numbers. So we'll also find the number of orders per year and frequency of order. So we'll work out here. So number of orders per year. Okay, so in a year we need how many units? We need 80,000 units. So in a year, so in each order we will make 1461 units as the order items. So this division will tell you how many times we will be like ordering. So we'll be like ordering 54.75 or else we'll round it off to 55. So in a year we will make 55 orders. In each order will be like ordering the EOQ of 1461 units. Now we'll find out like frequency of order. So frequency of order. So we'll do it in terms of days. We'll take 360 days in a year and divided by 55 times that we are going to order. So the answer comes to 6.5 days. It means every 6.5 days, okay, we'll be like ordering the units. So that is the frequency of order. Even though this question is not asking you the number of orders per year or frequency of order, it's just for illustration purpose that how these formulas work. We'll move on to the next problem. So the next problem is we need to find out what is the total purchase cost of the items that we have purchased. So there are like three costs which are associated. The first one is the purchase cost, where the annual units demanded or used in a year multiplied by the cost per unit will tell us the total worth of units that we have consumed. Next one is holding cost. So in a single order, how many units we are receiving? Minus 0 divided by 2, the entire divided by 2. This gives the average holding and multiply it by the holding cost per unit. That will give you the holding cost. The next one is ordering cost. So annual units demanded or used in a year divided by units received in one order. This will tell you like how many orders we would be like doing in a year. That multiplied by ordering cost per order will give you the total ordering cost. So add all these, you will get the total purchase cost. So we'll look at the next problem. For the earlier problem, we'll also work out these numbers. So the purchase price of an inventory is $25 per unit. Again, we have 3 months period of usage. 20,000 units is the 3-month usage. The annual holding cost associated is 6% and the order of placement is $20. So we'll start. In a year, how many units we are going to use? So we'll be like using 80,000 because that is what we calculated in the previous problem. Okay, the same problem. The cost of per unit is 25. So this will give you the total purchase cost. We will now work out the holding cost. In one order, how many units we will receive? So we just saw that in one order we will be like receiving the EOQ units of 1461 and minus 0. Divide this by 2 and multiply that answer with the holding cost per unit. So holding cost per unit is how much? Is 6%. 6% of what? 6% of the purchase price. So purchase price is 25. So we will solve this and then we will get the ordering cost. Ordering cost is annual units demanded or used, so that is 80,000 units divided by units received in an order, that is 1461. So this gives you the number of orders in a year. So every order costs you how much? It costs $20. So we'll multiply by 20. We'll get the total purchase cost. So we'll work out. So the first number comes to 20 lakhs. The second number comes to 1095. This number comes to 1095. The total comes to the total comes to 20 lakhs 2190. So that is about this sum. We'll move on to the next sum. So there's another set of problem called as EOQ with discounts. So here what happens is step 1 is compute the total annual purchase cost under EOQ. Then step 2 is compute the total annual purchase cost for the given units under which discount is available. Then step 3, choose the alternative which has the lowest cost. So these are the rules. First, find out the total purchase cost under EOQ. Then they will tell EOQ is not the ideal thing. There is going to be a higher amount of units that if you purchase, you will get a discount. So they will tell you that number of given units. So find out the total purchase cost for that. And among these, whichever is cheaper, choose that. So that is about EOQ with discounts. So we'll start. So we'll start for this problem. A company uses at the rate of 500 units per month. They are bought in at $1.2 each from the supplier. It costs 20 each time to place, regardless of the quantity ordered. The supplier offers a 5% discount on the purchase price for order quantities of about 2000 items or more. The current EOQ is 1000 units. Holding cost is 20% per annum of the value of inventory held. So we'll start out with this problem. So first what we'll do for the alternative, total purchase cost under EOQ. So we'll start with the purchase cost. So the purchase cost we'll calculate. For purchase cost is the total number of units in a year. So how many units we are going to buy in a year? We are going to buy 500 into 12. So how much is each unit? Each unit is bought at a price of $1.2. Next we will go to the holding cost. So holding cost is how many units we receive in a single order. Under EOQ we will get 1000 units minus 0 divided by 2 is in the formula. This number multiplied by the holding cost. So what is the holding cost? Holding cost is 20% of the value of item. So the value of item is $1.2. So that is the holding cost. So now we'll move on to the ordering cost. So ordering cost refers to the total items purchased in a year divided by the EOQ. EOQ is 1000. So this will give you the total number of orders. Orders into the ordering cost. Ordering cost is, it costs $20 each time to place an order. So the number here is 20. So we'll solve these. So the answer comes to 7200, 120, 120. The total answer comes to 7440. So this is the total purchase cost under EOQ. So we have done the step 1. We have to do the step 2. So step 2 is here. So we will find out what is the total purchase cost for getting the discount. Only if we purchase 2000 units, we'll get the discount of 5%. So we have to find out what's the cost of purchasing 2000 units. So we'll again start. We'll start with the purchase cost. Purchase cost here is, in a year we buy 500 units in a month into 12 into the purchase price per unit is, normally it is 1.2, but now we get a discount. The discount is a 5% discount. So what we'll do is we'll take it as 95% of this value. So 5% has gone as discount, 95% is the value of the product. So we'll take it like this and we'll compute. Then we have the holding cost. So the holding cost works like this. We'll be like purchasing 2000 units in every order. So we'll get 2000 units every time minus 0 divided by 2 is the formula. So multiply this with the holding cost. The holding cost is 20% of the unit cost. What is the unit? The unit price is not 1.2 like how we did earlier. Earlier we took 1.2 because the unit price was 1.2, but now the price is not 1.2, it's 1.2 into 95%. So what we'll do, we'll multiply 1.2 into 95%. So that will give you the, this will give you the new per unit cost. And finally we have the ordering cost. So in a year, this is the units that we are going to purchase divided by the number of units that are going to be held is 2000 into the ordering cost. The ordering cost, they say it's going to be 20 each time to place an order regardless of the quantity ordered. So it is always 20. So we'll get the answer when we total it. So the answer comes to 6840 228 and 60. So the total answer comes to 7128. So we have ended the question. Now our job was to find out whether we should accept the discount or not. If you look at the EOQ cost us how much? 7440, and the 2000 units purchase cost us 7128. So what happens is, as purchase of 2000 units gives a lower total cost, we can accept the discount. Okay, we can accept the discount and buy 2000 units at one shot. Okay, so that's about the EOQ with discounts. So we had the first step, the second step, and finally the third step. So that's about the answer. We'll move on to the next question. So the next one is receivables and payables management. So in receivables and payables management, we'll be like discussing about a topic called as early settlement discount. So we'll start. The early settlement discount works like this. If you are having a bills receivable, okay, and if you're going to give an early settlement discount to your customer, for you it is an expense. Hence, this expense should be lower than the overdraft that you are having. Okay, so that is about the concept here. In bills payable discount, what happens is the early settlement discount that you are going to accept from your supplier. Okay, so you're going to pay the early settlement discount. If you pay early, you will get this early settlement discount, and that is an income for you. This income should be higher than the overdraft rate. Okay, so it's going to be like vice versa or both. So ensure that you understand this, because this is a very important concept from the exam. So we'll start with an early settlement discount for receivables. So the early settlement discount has a formula. The formula is 100 divided by 100 minus the discount to the power of the, you might have 360 days, or you might have 12 months, okay, or you might even have 52 weeks, divided by the old days minus new days. Okay, so that is about the formula here. So the old refers to old days and n refers to the new days. So we'll solve the problem, you'll get a good idea. So we'll start. The company is offering a cash discount of 2.5 for receivables if they agree to pay debts within 1 month. The usual credit period is 3 months. What is the effective annualized cost of offering the discount, and should it be offered if the bank would loan the company 18%? So we'll start with the important numbers here. So 100 divided by 100 minus the discount is 2.5. Okay, so the inside part of the formula is over, to the power of, see how they have given the numbers. This is, if you settle in 1 month, that is the new month, new number, and the earlier number was 3 months. Okay, so the question revolves around in months, so it will be 12 in the numerator divided by the old number is 3 and the new number is 1. 100 divided by 97.5 to the power of 12 divided by 2, that would give you 6. So if you're going to solve it, we'll solve it here. So if we solve it, we'll get 1.025 to the power of 6. If we solve that, we'll get 1.164. So throughout this formula, okay, always have -1 and into 100. Okay, -1 and into 100, and again have -1 into 100. Why do we have it? Because this number that we have here, okay, includes the principal and the interest. So -1 removes the principal part of it, and only when we multiply by 100 we'll get the interest rate. So the interest rate is, in percentage, it is 16.4. So what was the rule that we had? Should we now accept the, should we give early settlement discount, or should we not give? The answer, we'll check it out. See, the 16.4 is a cost for the company because they are giving the discount. Okay, but if the company is going to borrow at bank, they have to pay 18%. So which is better? It is better to give the discount and get the funds earlier, because if they can't get the funds through this manner, if they go to the bank and borrow, they have to borrow at 18%. So 16.4 is much cheaper than the 18%. ESD is lower than the overdraft. Okay, hence issue ESD. Okay, so the company can go with early settlement discount. So that's about this problem. We'll move on to the next one. So here we have another problem. So this is an early settlement discount from the payables angle. So we'll do this also. One supplier has offered a discount of 2% on an invoice of 7,500 if payment is made within 1 month rather than 3 months normally taken to pay. If box's overdraft rate is 10%, is it financially worth for the company to accept the discount and pay early? So some other supplier is offering us a 2% discount. Should we accept it or not? So that is the question. So we'll start with the ESD. So the ESD formula works like how? 100 divided by 100 minus D to the power of 12, because that is what given in the question. It is in months, divided by old minus new. So once this answer is over, we have to like direct it from my minus 1 into 100. So we'll start 100 divided by 100 minus discount is 2. So we'll take it as 2% to the power of 12 divided by old months. Earlier it took 3 months. The new month is like just 1 month. So 3 minus 1. So it's again minus 1 and into 100. So the number comes to 100 divided by 98 to the power of 6, again minus 1 into 100. So we'll continue here. So equal to, so the number comes to 1.1288, again minus 1 into 100. So the answer comes to 0.1288 into 100. So the answer comes to 12.88. So if you're going to accept the discount, it will be like getting a benefit of 12.88. So how this actually works? See, if we are going to pay the supplier, we'll have a benefit of 12.88. But assume that we don't have money, we have to borrow. So we usually borrow at an overdraft and then pay the supplier. So what happens is, as the ESD is higher than the OD overdraft, hence it is acceptable. Okay, hence it is acceptable to pay early. Okay, you can pay now early, because if you borrow from the bank, it's 10%. Borrow at 10% from the bank and pay your supplier sooner. But if you pay him, you will get a benefit of 12.88. So the benefit is much higher than the loan that you will get from the bank. So go for the payables discount. So that's about this problem. We'll move on to the next. So again, it's a payables question. A supplier has offered CB an early discount of 3% if the payment is made within 20 days. CB currently takes 58 days from the supplier. So they are also saying calculate to the nearest 0.1% of effective annual interest, and you should assume 365 days. Okay, so we'll work out for this. So it's again 100 divided by 100 minus 3 to the power of, as it is in days and they have given you how many days it is in a year. In some questions it's 365, in some questions it is 360 only, but here they have given you, and the old day to settle is 58 days and the new days to settle is 20 days. So you have to calculate this, and it's again minus 1 and into 100. So we'll try to calculate this one. So the numerator inside comes to 10309 to the power of 9.6, again minus 1 into 100. So the number comes to 1.339. Again, minus 1 into 100. So if you minus 1, that comes to 0.339 into 100. So that comes to 33.4%. So that's about the answer we got for this problem. As there's no overdraft rate here, we don't need to compare and tell whether it's better or not. So the answer ends with here. So now we'll move on to cash management. So we'll start from the Baumol model. So there are some assumptions here. We'll start from the formula. The formula is Q equals to 2COD divided by CH. That means CO refers to transaction cost, D refers to the demand of cash over a period, and CH refers to the holding of cash. This is nothing but the same EOQ. It's again the same 2AB by CS. It's a similar formula, but it's done for cash management purpose. So we'll try to solve this problem. So we have the question here. A company generates 10,000 per month excess cash, which it intends to invest in short-term securities. The interest rate it can expect to earn on its investment is 5%. The transaction cost associated with each separate investment is constant 50. So we'll put it like this. So he's asking what is the optimum cash to be raised in each transaction. So we'll take it as Q. So Q refers to 2 into annual demand for cash. So the annual demand for cash is, they have given it as 10,000 per month. So we'll convert it into 12 months into the transaction cost. The transaction cost is 50 divided by the holding cost. So the holding cost is 5%. Okay. So that's it. We have to just multiply and get the answer. Divided by 5%. 15492. Okay. So we have got the answer. So we still have the question left. How many transactions will arise in each year? So in a year, so we'll start with the B. So we'll start as number of transactions per year. So in a year, we totally required 1,20,000 amount of cash, and we in each transaction we have to raise 15,492. Gives you, we have to totally make 7.7 transactions per year. So that's about the second one. What is the cost of making those transactions? So what is the transaction cost he's asking? So there is 7.7 transactions that we have to make, and each transaction has a cost of 50. So multiply by 50 will. So the last question is, what is the opportunity cost of holding cash per annum? So the holding cost will be, see, if we are going to raise the cash, we will be like raising 15,492. We'll wait up to it becomes 0. So this is the average amount of cash that you are holding, and the transaction or the holding cost is 5%. That's what is being given here. The holding cost is 5%. So when we multiply like this, we'll get the answer. So the answer comes to 387. So that's about this problem. That's about the Baumol problem. We'll move on to the next one. So we'll move on to the next problem. This is called as the Miller-Orr model. So this is how it works. There's something called as a return point, which is equal to the lower limit plus 1/3 of spread. There's something called as an upper limit, which is a lower limit plus spread. The lower limit will always be given in the question, and there is also a spread, because spread is used in both the return point as well as the upper limit. So the spread is 3 into 3/4 into transaction cost into variance of daily cash flow divided by interest rate per day. So first you have to solve this part, then you have to take the power of 1/3. After you multiply it by 1/3, you have to take this answer and you have to multiply it by 3. Okay, so here the variance is also the standard deviation of a cash flow into its square, and interest rate per day refers to annual interest rate divided by 365. So first we will start from the spread, because spread is required for both the return point and the upper limit. So we'll start from the spread. So spread formula is already given there. Okay, so we'll just substitute the numbers. So the formula works like 3 into, you have to get an answer for this, so that is 3 by 4 into the transaction cost. So we'll read the question and we'll get these numbers. The minimum cash balance of 20,000 is required at Miller-Orr Co, and transferring money to or from the bank costs 50 per transaction. Inspection cost of daily cash flows over the past year suggests that the standard deviation is 3,000 per day, and hence the variance is 9 million. The interest rate is 0.03% per day. He is asking you to calculate spread between the upper and lower limit, as well as the upper limit and the return point. So he is asking all the numbers here. So we'll take all the numbers and we'll do it. So first we need the transaction cost. Transaction cost is here, it is 50 multiplied by the variance of daily cash flow. The variance of daily cash flow is 9 million and then we need to divide all these by interest rate per day. So the interest rate per day is 0.03 percentage. So solve all this to the power of 1 by 3. So we'll try to solve. So first solve the inside part of the formula. So if you solve the inside of it, you will be like getting, your numerator will be 33750000 another single 0 divided by 0.0003. To this you have to multiply or get the power of 0.3334. okay, and let's see how this works. So when you solve the inside part of the formula, okay, all these things put together, your answer comes to 10,400. So the total spread comes to 31,200. So that is about the spread. So the other part of the answer is, we need the return point, we need the upper limit, we need the lower limit. So the return point is the lower limit. So usually that will be given in the problem. So they have stated that the minimum cash balance is 20,000. So that is the lower limit, 20,000. So all the part of your questions will have the lower limit. Okay, return point will also have lower limit, and upper limit also has the lower limit. So we have to add. The return point is lower limit plus 1/3 of the spread. So spread we have calculated as 31,200, and the upper limit is also lower limit plus spread. We can directly add that. So we'll get the answer. So the answer for the return point is 30,400, and the answer for upper limit is 51,200. So that is the question here. Okay, so if you want to draw a diagram, you can draw a diagram like this. So this side refers to the time or year, and this side we can refer it to as upper limit, return point, and lower limit. Okay, so whenever the cash goes beyond this level, that is when it reaches 51,200, we have to sell and bring it to the return point of 3,400. And whenever the cash goes to the lower limit, okay, lower limit is set here, if it touches here, we have to sell the securities and bring it to the return point. So what is our lower limit? It is 20,000. So the cash position should not go above 51,200, and it should not go below 20,000. It should be within this spread. So that's about the Miller-Orr model. Now we'll move on to the computation of working capital requirement. So to find out the cash operating cycle, we can have this kind of format. So this is a lengthier format where we add the raw material days less the payable days plus the WIP days or work in progress days plus finished goods holding days and plus the receivables days. So actually this is a minus, or there can also be a simplified cycle. For example, for trading companies or retailing companies, we'll only have the inventory holding period less the payables and plus the receivables. So again here it is just a negative number. So you can have this kind of a format. So if the question gives you an more data, use this approach, or if it gives only a little bit of information, use this approach. Either way they are similar and same. So we'll start from this problem. In this problem he says the following information has been calculated for ECO. What is the length of working capital cycle? So he's just asking us to add all these days and get it. Trade receivable days, add it. Raw material inventory turnover period days, add it. Work in progress days, add it. Trade payables days, minus it. Finished goods days, add it. When you add and subtract all these, work out this, you will be like getting this answer. So the answer is 103 days. So that's about the computation of working capital. So we have come to the end of all the small problems. We have to look at the lengthier problems. Okay, so we have come to the end of our video. So thank you very much for watching our video. We'll meet in the next video.